Hello everybody, welcome to the workbench of the old school CW transmitter part 8. Last part I said I would come back to you at part 7. That was an error. So anyway chaps, I done some work on the transmitter, and I connected them up again with power supply, and I will test now the end valve, and at the same time we also can test if there is any spurious frequencies present. The oscillator is not connected, but then again every well-built transmitter can have spurious frequencies in it without have any drive. So if there is any there, it should be noticeable. So we are not at 160 meters. And we're aside from that, so we are working with about 250 volts, and I'm going to tell you why. This power supply will only provide to 60 milliamps, so keep it down a little bit. Otherwise I get a voltage drop on the power supply, and that will in turn give it too much current for that valve that is regulating the voltage. Alright, so I'll put them on now. So I'll warm the valve up, and this is the milliamp, so I will straight away zoom in on there on that meter. You have to excuse the earthquake, so otherwise you won't be able to see it. So I'll focus it, and there we go. So I'll go voltage holography is glowing, yes, it's nicely. I'll put the voltage on, yeah, and I'll put them on, have a look, about 250 volts. I won't go higher than that. Anyway, as you will see, it will do nothing, because the circuit is open. The circuit is open, and it will do anything. So I changed over from screen grid to cathode keying. So we're not keying in the screen grid, and I'll tell you why. Because the high voltage will come on this key, and then it's not very pleasant. So I swapped over to the cathode. So I'll plug him in. There we go. Alright, and as I keep it on, there we go. The key, you see the meter. Now, I'll see if we see any dips. If a spurious frequency is present, we're turning the capacitor, we will see a dip. There is no spurious frequency present, so we go to the next band. There is no spurious frequency. If there is any, you see a dip. Nothing. Well, it doesn't show anything spurious frequencies, so we see you have to have another method to find out. Lithography, yeah, we had 300 volts, and we're now working at 300 volts, so that's not bad, is it? Here. I'll turn on a little bit for myself, but I can't see properly. No, it's nothing. But I do notice there's a current difference between 160 and 80. Odd. Shouldn't be though. Yeah, there is current difference. Okay. Anyway, that doesn't mean anything. So, so far as I can see, there are no parasites present. So if I open them up, and I would turn the tuning capacitor, I must see a dip if there are any nothing. I see no, that's so far as we can go with this. We'll turn the voltage down here to 110, and I will see immediately, you see the current goes down. Let me try this this joke again. Nothing. No parasites. No parasites. No parasites. Okay. Now I'll switch them off, and I will engage again, so the voltage will drain down. That's okay. Now I'll switch this off. Okay. Disconnect everything, and I'm going to show you what I've done. There we go. Just get this out of the way. Get the leads out. They're still dangerous if they are still in. Okay. There you go, guys. I'll put it on the floor right now. Anyway, so we have everything together. Yep. This one too. I will hang this back where it belongs, out of the way. So, there we go. Got rid of that. So I'm going to show you now what I've done. I'll reposition the camera a little bit. Zoom out. That's about right. Refocus. Okay, there you go, guys. I'll turn around them and we'll be able to see this. Now, what have I done? I put in the transformer, I put in the power supply or part power supply from for the end valve, and I put a power supply in here on the bottom for the oscillator. The only thing we have to do now is to connect everything up, and then get the power supply in still for our frequency counter. Get the connections all up, and then that's done so far as I know. So I will shut down the camera, do all those things. Get it all put in, like that. See, I made that already. I made the top part also. Can go on. So you see we are making progress, and when we are that far in this stage, then the real stuff start to happen. So then we really have a go at what is going on. So so far so good. I will shut the camera down for a moment, and well, for you a moment, and for me is it perhaps an hour or so or more. And I'll come back to you and talk a little bit about it still, and and then we proceed to the end testing, see what the thing actually does. So I will see you the next time. Hi everybody. Well, gentlemen, I made quite some progress here. There's some good news and there's also a bit of bad news. Well, I'll come straight to it. You can see our frequency meter here. It doesn't operate properly, so anyways there's a lot of trouble getting this thing going. I tried several things now, and I decided to replace this frequency meter for one of I have on my signal generator, so I ordered that one. So as soon as she comes in, I will replace that one with that one, with the other frequency meter, so frequency counter. What I have done, gentlemen or chaps, I finished the power supply. There were some issues after that with hum. I told you in the other video there could be a problem with putting those transformers into the compartment here, that it could produce hum. Well, it did produce hum, but not because of magnetic fields or something like that. No, it was purely only because our capacitors were not big enough to get the hum out of it. So I put two big capacitors in there at the end for the end stage, and there's about twice 330 microfarads, so the 660 plus the 10 was up here, just 670. Well, there is no hum anymore, so we've solved that problem. But anyway, as I told you, I replace this frequency counter with another one. These are quite big, so I put them on front just as done with the frequency counter. Anyway, having said all this, I did some checking, and you can see he's on 3.5 megahertz. So I put the thing on, and I put the radio on as well, so on that frequency. So we have here the dummy, but you can show the voltage which comes out of it, and there's not much because everything has to be adjusted still. So we're not at the end product, and we have here the SVR meter for power and reflection. So we have that in between. That's also self-built. So there we go. If I put the power on the end stage now, and then you can hear the radio is on a frequency. Hold on. Really? We have 350. Should be. Well, perhaps it's not that low. We'll try again. Hold on. No, it's a bit higher, so it doesn't matter. I have to adjust it a bit. Hold on. There you go. It's not properly tuned. Yeah. I think it's in my hand, so I can tune this properly. Hold on. You can see the oscillator is pulling away a little bit. It's not tuned properly. You can see that thing works, and works well. So there you go, chaps. The next thing we have to do, because you hear it now in the background, you hear a little sound from the oscillator, just slight, and it's only because it's not boxed in, so everything is open, the signal come out and goes all over. So anyway, if everything is shut down, you can make a proper adjustment. We can make another one, but let's try. Let's try this one. Shouldn't do that actually, but I'll try. It's on the dummy load, so it shouldn't go on the antenna. And then go. Let's have a look with me. 536. Yep. Yeah. I'll switch him off. So what we have to do now is to fix the connection for the valve. Yesterday had 5 watts nearly coming out of it, and during that time the excitation went down to 1.2 watts. So there's a possibility one of the capacitors, coupling capacitor, probably, I suspect, that it's leaking. So this big valve AL34 has about 30 volts minus on his grid and on G1, and so he can cope with that. So to mitigate that, but there again you use all your ability to get the power up. So what I'm going to do now is sort this out, of course, and I tried the other bands and they work as well, and I will be straight with you. The 40 meters, the 160 is, I have no excitation on 160 anymore. Yesterday I had that still, so that's gone. But I had them working on 160 and on 80, and I had them working on 40. 20 meters he didn't want to do. He didn't want to, didn't get any dip on that at all. So that's probably because the signal that's coming into the end valve is too small to give you any proper signal out of the anode or onto the antenna. So what I have to do now is to adjust the coil that is in that place with the capacitor, and it only works harmonics. So it has all to do with harmonics because I have no tuned system in there between the valves. Normally you can also put a coil in there with a capacitor, and then you can adjust the anode from the oscillator, so that you get the maximum signal out of it, because it is in resonance then, and you get a big amplitude then, and that will end up on the grid from the end valve. Consequently, that end valve will amplify that and make it signal much more bigger to go to the antenna. So I think I've made my point, so that's what I have to do. This one will be replaced, and I'll show you that one by I'll go up a little bit. I will put them on, you can see it. Now you can see this is the display, but it's going to go on the transmitter, because I think that is the best thing to do, because he doesn't make any trouble. So he just does his job. And anyway, I think it is has been sold, but you have to do a lot of things on there with another transistor or a FET in there to get the right impedance and the right sensitivity. I don't have the time nor the energy to go all after that, so I've took a shortcut, and I'm going to go with my frequency counter. I want to put that. He's bigger. I want to have a sticking out thingy up here, so that doesn't matter. But anyway, as you can see, gentlemen, this is the end of what was it? What part was it? Have a look. I really don't know anymore. I think I'm getting older. That's the main trouble. That's when you're getting old. Your memory is not near what it was. So anyway, so we'll have to live with that. And we are on part 7. This is part 8. So gents, I will shut down part 8. I will have a go at the transmitter, or old school CW transmitter. And I can assure you one thing, I won't let go before this is all working as it should. So I did quite a bit of work on there already. I'm sorry chaps, I didn't show you what I've done, so hold on. But at least I owe you that. I'll show you how the thing looks like now. And there's a spare to say that you have. Don't expect me to show you that, so I should do that. I'll take that away. And there we go. Put that key off. A lot of stuff here in this. Let's have to clear up a little bit. So, we'll take that antenna part off. Well, now then, which I'll show you on top. I put something underneath that you can see. I'll explain it, I will talk about it a little bit. So, to see what you can see, I will zoom in a little bit so that this becomes more clear for you. I'll position the camera a bit. Let's leave it there. Well, I took a picture just now. My this camera can make pictures also, so if I get my finger too long on the button, we say click, and then gone was the recording. So I had to do it again. So let's have a look. Now, anyway, that's over here. You can see those capacitors what I put in. Over here you can see the capacitors. I put a resistor on there. We have here a 33 microfarad, and I put a resistor in there, and I put in another capacitor there, linked up to that one, and we bridge again with a little resistor to the next one, and then down to the feet of the valve. Anyway, that's the story, isn't it? So anyway, what I was saying, this thing has to go. You can see how neatly it fits all in. I'll be honest with you, when I started it up with that, those two capacitors, there was quite a hum. I can assure you that. There was quite a hum. I was really taken aback about it, how big that hum was. And I thought, in the first instance, perhaps was better to get all the transformers out of this compartment and put it in another box. I was that far, but fortunately my brain is working still, so I didn't know it wasn't this transformer per se. So anyway, you know what I mean. I'll show you the other side. And I'll put it in there. See, what has to be retuned is this little coil here with a capacitor that is there. Can you see it? Yeah. That has to be retuned. That has to be put properly done. I have to investigate this little capacitor, what is coming through there. Let's have a look. Where is he? Where are you? Oh, here. It's underneath here. I suspect this capacitor. I will change, check the screen voltage on the end valve. There is a possibility to make this work on mid-wave. There is a possibility, but you have to put more capacitance into the system. I don't know, and I told you chaps already, this connection to the 20 meter band, I was not sure of that, and I'm still not sure of that. So I have to find out if you have enough excitation from this valve to the other one to make this work. So the signal can be too small. You can forget it. So there has to be, yes, I have to do something about that. I will do that. You can see this little coil here. Inside there is a little resistor from 1 watt, and it's about 100 ohms. This prevents spurious frequency is onto this coil. So this will stop that. This parasitic stopper is that. You could put one on the grid also on pin 5 where the capacitor is connected to. So basically now what is all concerns is what's coming from here going to there. This point we have to check. That will have an influence on our end result. So that's what I'm going to do. And there you have it, gentlemen. The other thing what I should do perhaps is put a screen between that. I don't have, because it is necessary. I have to check it out. There are also some things I have to check out, and I will not let go before this all is as it should. Okay? And then I will come back to you with the next part, and then we we go through all the bands, and then we use another receiver next to it. I have another nice thing I have to tell you. I'm going to tell you that. I made it a couple of months, a year perhaps later. It is away. Does it want? Does it want? Anyway, let's just disconnect it for a moment. And it's not boxed in either, so that the signal can come out of here as well. And there we go. Okay, there you go. I will put this transmitter aside for a moment, and I'm going to show you this. I've made an SVR, an RX TX switch. Yeah, that consists of one valve. I think I have put that on block spot. I think this thing. As you can see here, the SVR meter, and this is what blocks the signal from the transmitter to the receiver. You can put your receiver on that. You can put your transmitter on that, and you can put that to the antenna, and then you have an SVR meter for the wattage and the reflection. so that's very nice. You can use it on QRP, 10 watts, and you can use it in 100 watts. So it's a very nice device. I made a couple of months or a year ago. I don't know it actually when I made it, so you can look at it. And it's quite nice, you know, and I'm going to employ that with another receiver. I will get that out from the bench, and I'll add it anyway, so just as well to tell you that. Well, to switch that radio off for a minute. There we go, get that out of the way here. And see if he connected up. No, it's not. So, hold on. I'll show you something. Whoa, hilfe! I had an accident here. Anyway, I just wanted to show you. I will open in a later video. I will open this thing up. I'll show you something. There's a receiver, and I put in a video on there as well. And this has 3 bands. He has 3 bands. He has 80, 40 and 20 meter. And they have here the tuning of it. So you put it on there with 3.5 megahertz, and then you can retune it here. And you have a tickler. It's just a regen radio, 3 band regen radio. A volume, and you have a standby switch. So I want you, when we come back to this, and we're going to make a QSO, we're going to use those two together with this little fellow here. So see, it's a nice combination. So I will make another video on that one, so I can go through it. You can also find it on Blogspot, where I show you how I build it. So he has fun little feature on this. This is the antenna. This is a separate valve that keeps, because he is in regen, keeps the frequency of the antenna what the oscillator makes. You know, it is an oscillator. It is now nearly an oscillator. It's at the highest point when it's more sensitive, and then you can receive it. On the other hand, there is oscillation, and that oscillation goes onto the antenna. And in actual fact, you're not even allowed to have one of those radios. So to prevent that that signal goes onto the antenna, I put an extra valve in there, and that will block that. And believe it or not, in the Second World War, when they had the power set, they use also a regen receiver that puts out a signal, and the Germans picked that signal up, and that's the way they were able to find those people. And if they caught them, they put them against the wall, put them in a concentration camp. So that was the result of that radio. So it was very, very dangerous to have a power set in those days. And still there were some problems also with making a connection with England. So, but I'm not going into that now because it goes me too far astray. Anyway, you see this the apparatus that I want to use together with our old school transmitter. We can use those together. We put a headphone in there. We have no speaker, so it's nice and easy. We use this as a blocking, so we can switch this receiver off to put them on standby. So it is absolutely a very nice setup actually. So I really want to try this and making QSO with it. So anyway, gentlemen, enough chatter. I'm going to conclude this part 8, and I promise you I'll come back with part 9. So so having said that, if you like the video, give me a thumbs up. That would be very nice. and if you have some questions, you can put it to me, and I'll try to answer them. So, mind you, I don't know everything. You know, I'm an amateur. I'm an amateur since I was 10 years old. So I learned all that in practice, and not by putting my nose in books and this, that, or the other. So anyway, chaps, I'm going to conclude this part, and I'll see you next time. All right.